Okay, we're up and running, and I will share my screen, and then I'll look for some feedback from you guys. Just a second or so. So, are you guys seeing my screen?
Yes, sir.
You got that, Jeremy?
Yes, sir.
Okay, good. So, 1.7 questions. Let's open it up. And just a reminder to everybody out there, if you send a text message to 262-510-2046, if you're only on the YouTube link, you can still send me questions and feedback. Okay, so questions.
Can I see number 33?
You bet. Number 33. Okay, we'll do that one live. So I'm gonna change my screen so I can write. Okay. Number 33. Number 33. 1/2 times the quantity, 8x plus 1, is greater than or equal to, let me try that one again. (3x plus 5/2). With the directions, solve the inequality and sketch the solution on the real number line. All right, so I'm assuming, Noah, you did the distributive property on the left first?
Yeah, I don't know what I did. I didn't know where to really start. I mean, I thought to do it that way.
Okay, that's good. 1/2 times 8x is 4x. 1/2 times plus 1 is plus 1/2. So now it's time to think about getting the x's together. Usually my advice to people is get rid of the smaller one. So I'd want to get rid of the 3x by subtracting it from both sides. So that would leave you with 1x plus 1/2 is greater than or equal to 5/2. And then all I got to do to get x alone is get rid of that 1/2, so subtract a 1/2. And by the way, I never did the rule with inequalities. You have to reverse the inequality if you what? Multiply or divide by a negative. But I haven't done any multiplying or dividing, so. So anyway, what's 5/2 minus 1/2? It's 4/2, and another name for 4/2 is 2. And then to finish it up on a number line, I don't know, do you want me to do it the old way or the new way, Noah? Anyway, the new way is probably what the book has. So greater than or equal to 2, so we got to make a square bar right at 2, and then the shading goes, because it's greater than, to the right. So that would be the graphical part of that one. Any questions?
No, I was just making sure I did it right.
Okay. That looks like 33.
Yeah.
All right. Are there some other, what's next for the questions? I think I just got one via text message. Number 59. Okay, 59 from mystery phone number. By the way, in the future, if you send me a text message, it would be awesome if you would include your name. But it's not necessary. Okay, 59. Let's go to that next. Okay, let's see if I copied this correctly. 2 times the absolute value of x plus 10 is greater than or equal to 9. Okay. So you want to get the absolute value isolated. So I really want to get that 2 out of there. So step 1 is divide both sides by 2. Now that we got, once you get to this part right here where you got the absolute value by itself, now you can break this into 2 portions. The first part, on the left, just ignore the absolute value signs completely. And on the second part, I have to do 2 things. I have to flip the inequality around. See how I did that right here? And I have to do the other sign. And because this is an absolute value greater than, it means we're going to have a union, we're going to have a split graph, so a split answer, so to speak. So anyway, then just do the algebra. There's very little algebra. Subtract 10 from both sides. Well, what is 10 in terms of halves? It's actually 20 halves. So if you subtract 20 halves from 9 halves, you get a negative 11 halves. And on the left, same thing. Subtract 20 halves, but this time you've got a negative 9 halves minus another 20 halves is negative 29 halves, or negative 14 and a half. So you notice on this side we've got an answer greater than or equal to something, and on this side we've got an answer less than or equal to. So here's the less than one, negative 14 and a half, less. And then on the other side, we've got greater than, negative 5.5 to the right. And the answer is literally a what? A split. There are 2 parts to the answer. Any part over here or over here is going to be good. You should, by the way, I haven't said this, but you can spot check. For example, pick a number that's less than negative 14.5, like negative 15. Let's just quick spot check it. If you plug in a negative 15, what's a negative? Go back to the original up here on the top. What's negative 15 plus 10? Negative 5. What's the absolute value of negative 5? Plus 5. And what's 2 times 5? 10. Is 10 greater than or equal to 9? Yeah, so it checks. And then pick a number that's greater than negative 5.5. Like negative 5. Oh, is that the one I just did? No, that's not. So anyway, I'm going to let you guys do that. I see I got some more messages, so let me just check. Okay. So I got 3 more that we can look at. They are 17, 89, and 77. All right. And hopefully, whoever asked about 59, hopefully I answered your question. All right, I'm going to go backwards, and let's do 17 next. I got that request. Okay, 17 gives the problem as you see there. Absolute value of x minus 10 is greater than or equal to 3. And then you're supposed to try A, B, C, and D. You're supposed to let me know if those work. So this is, I mean, I didn't label them, but, this is A, B, part C, and part D here. You just plug them in and you see if it works. So I plugged in 13. 13 minus 10 is 3. Absolute value of 3. Is that greater than or equal to 3? Yeah, true is what my T means. Does negative 1 work? Yep, negative 11. Absolute value of negative 11 is 11. Is 11 greater than or equal to 3? Yep, so that's a true. Does 14 work? 14 minus 10 is 4. Absolute value of 4 is 4. Is 4 greater than or equal to 3? Yep. And how about 9? 9 minus 10, negative 1. Absolute value of negative 1 is positive 1. That is not greater than or equal to 3. So Parts A, B, and C all work. Part D did not. And let's see, I just got another text message. Let me check. 17. Okay, we just did it. So hopefully, I got several requests for this particular one. So there really wasn't any algebra to do here. You were simply supposed to substitute and see if it works or not. 3 of them worked, 1 of them did not. Okay, I got a request for 77, so let's do that next. And that one I'm going to have to create a slide for, so we'll do that. So number 77, find it here. The square root of x plus 3. And what are the directions here? Find the intervals on the real number line for which the radicand is non-negative. So non-negative just means 0 or bigger. The radicand is just a fancy name for the thing that's underneath the root sign. So in other words, they're saying find out when that is 0 or above. So if it's greater than 0 or equal to 0, then it's not going to be negative. So that's what they mean. This is the radicand. That's just a nickname for the thing underneath the radical sign. So really all we got to do is solve this. Subtract 3 from both sides. And you've done it. So what values of x do we need for this radicand not to be negative? Answer, it's got to be -3 or bigger. So that's really all there was to number 77. I'm going to go now. Again, if you want to, I hope I answered the request adequately. If you need to ask me something specifically, you'll have to send another text back to me. But in the meantime, 89 is the next request. Okay, number 89. All right, so 89 says all real numbers more than 5 units from 3. So the distance from 3, and this is how you write the distance, you know, I guess I could have, this is how you write the distance from -3. Actually, it really looks like this. Okay, the distance from -3, x minus that -3. Well, I just simplified that. What is x minus a -3? It's x plus 3. So this is the way you write the distance from -3, and the fact that it's supposed to be greater than 5, you just write greater than 5. So, absolute value problem. Good news, the absolute value is isolated, so we can right away break it into 2 parts. Look below the graph here. First one, just ignore the absolute value signs. Do the algebra, really quick, easy problem there. And on the other side, you have to do 2 things, remember. You have to reverse the greater than symbol to a less than symbol, and you have to change the sign on the non-absolute value side. Then do the algebra. And then, because it's a great absolute value greater than, it's an or, it's going to be one of these split graphs. So then, basically, just show, I think you were supposed to plot it, weren't you? Yeah. It says, use absolute. Anyway, I'm showing the graph. I'm not quite sure. So less than or equal to -8. I'm sorry, not equal, just less than -8. I use the what? Kind of the parenthesis and shaded to the left because it's less than, and then greater than 2. Again, the parenthesis shaded to the right. So this should pretty much wrap up 89. Other questions? I'm just looking on text messages. I think I've covered the ones that were sent by text. Noah, Jeremy, any other 1-7 things you want to look at? Just so you guys. No? Okay.
I'm okay.
All right. Thanks, guys.
Mm-hmm.
Okay, then we're going to start. And by the way, I don't know if you noticed, but lesson 1-8, if you looked a little bit in the book, you would see, guess what? That's the last lesson in this chapter. So let me just talk schedule here for a minute. Okay, that means you know, we got to wrap up. We're going to be wrapping up the chapter, and we're going to have a test. The schedule would be today we take lesson 1-8. Then when we get together again on tomorrow on Wednesday, I'll call that review 1. We'll open up with questions about this lesson that we're going to take today, and then we will start digging into all of chapter 1 and getting ready. I'm not going to formally assign it, but there is a practice test in the book, and there's a review, and those would be a great place to look to see if you're ready. Come back with questions. We will have a review 2 day on Friday. And so right now it looks like our test on chapter 1 will be next Monday. Okay, so 1-8 today, Wednesday, our first day of chapter 1 review, Friday, our second day of chapter 1 review, Monday, test on chapter 1. So everybody, that's the schedule. And here's our last lesson. It's more inequalities. We're going to throw in, what do they have? The first objective, solve polynomial inequalities. By that we mean, for today you only had linear inequalities. You never had any, we didn't have any exponents today, did we? Well, guess what? We're going to have some exponents now. We're only going to we're not going to go too high, but we're going to deal with nonlinear. And then number 2, rational inequalities. That means algebraic fractions with an inequality sign. We've done them with equal, but we haven't done them with inequalities. And number 3, see how the timing goes. Use that to solve some real life problems. Okay. So let's take a look at here's our first example of a polynomial inequality. Okay, x squared minus 2x minus 3 is less than 0. You know, we've never had, in a quadratic, we've never used anything other than an equal sign there. So, but you notice what I did in the very first line here? Right away, I changed it into an equation. Now, let me explain. What you need to do with an inequality, what we're trying to do is find out when this parabola in the top line here, when that thing is below the x-axis. That's what less than 0 means. So when will this parabola be below the x-axis? And by the way, I do have to apologize for this really ugly black sketch here on the right, but that was a real quick parabola sketch. And where is it below? Well, you see how it's between this point and this point? Anyway, let's do the algebra next. So first we want to find the crossing points. Where does this parabola cross? So when is it equal? Even though we know it's a less than problem, when is it equal? Well, this one turned out to be factorable. So I factored it. Just like we learned, I set each factor equal to 0, and I found 2 crossing points. +3 and -1. And you see, oh, boy, I even whiffed here, didn't I, on the +3. But anyway, you have a parabola that's opening upward, and it's crossing at those 2 points. So now that I know the crossing points, when is the parabola below? When it's to the right of -1, and when it's to the left of +3. Both of these ways are a correct answer. The one on top just says what? X is between -1 and 3. Now this looks like an ordered pair down here, doesn't it? But that's really, isn't that just interval notation? Interval, the rounded parenthesis, means not equal to -1, but -1 on the border. And this rounded one over here says up to 3, but not including the 3. I know, this really looks like an ordered pair. That can be a little confusing. I can't remember. If you look in the back of the book, I think you might be getting interval notation. I think that might be what you see. I can't quite remember, and maybe somebody can remind me. I didn't have a chance to look ahead of time. So, what's different here? Not a lot from what we've done before. I mean, we found the crossing points. You guys know how to solve a polynomial by factoring. But actually, the crossing points are important, but that wasn't the real question. The real question is, when is it below? Oh, well, between those 2 points we just found. So just one little adjustment at the end. When is it below? When it's between -1 and 3. So there's a lot of review in this example, but just that little different viewpoint on the answer. You just got to go one step further there. All right, let's look at, now here's one directly from the assignment. This is number 2, so if you have your book, you can go take a look at page 158. And on page 158, this is number 2. And it says, determine whether each value of x is a solution. So this is one of those multiple choice jobs again, okay? So actually, I did too much here. When they give you a problem like that, it means plug it in and tell me if it works. So you can see what the answer is here, I hope. When is this parabola above? By the way, you see the difference? It's greater than or equal to, so that means above or on. Again, kind of an ugly sketch here, a little bit smoother. By the way, here's a professional one lurking in the background. When is this parabola above or on the x-axis? Well, when it's, here are the crossing points, 3 and 4. I'm sorry, -3 and 4. When it's what? To the left of -3 or -3, and when it's on 4 or to the right of it, right? Because the parabola would go up and keep getting wider. This would keep going wider as this goes up, and I can't show you because it's off the screen, but it keeps getting wider. So those would all be above. So now, what they asked you is 5 above? So you can see on the graph it will be, right? Because it's to the right of 4, but let's just plug it in. You can do it just by substitution. 5 squared is 25. 25 minus 5 is 20. And what's 20 minus 12? 8. Is 8 bigger than or equal to 0? Yeah. So you can, I did more than I had to. But it's good because I'm teaching this to you and I wanted to show you the full. So let's do one more. Let's do D. X equals -3. Does that work? Well, you can see on the graph it does. It is on the x-axis, and there's an equal sign here, so we're good. But let's plug it in and try. -3 squared is +9. And what's 9 minus a -3? That actually becomes 9 plus 3, or 12. And what's 12 minus 12? 0. Is 0 equal to or bigger than 12? Yep. So that's one of those true-false things again, like the problem we looked at from the last assignment. So again, I did too much here, but we're in the process of trying to show you. Okay, I do have a question that just came in. How do you know if you have to write it as an or as an and? Good question. All right. I'm going to insert a slide to help answer that. And we'll see if you get my hen sketching here. if you have an absolute value less than problem or equal problem, then that's going to be and that's going to be, whoops, sorry, and that's going to be intersection. Are you guys, do you have the screen back? Hopefully. Give me a thumbs up, Jeremy, or no. Okay, good. And if you have an absolute value greater than problem, that is or union. So in answer to the question that was sent from 414-380-1331, there's the answer to your question. Again, I don't know what your name is, whoever sent that, but that's a good question. Excellent question. So anytime you, you know, inside here you're going to have whatever x expression, okay? But if you have an absolute value and it's followed by a less than or an equal, it's an and, intersection. If it's absolute value with a greater than, it's an or. So this is an or situation, and sure enough, look, we got a split graph. Where is it above? Well, when it's -3 or to the left, or when it's +4 or to the right. And it's a greater than problem, so you know, I should have left the equal sign off of there. So let me just do one addendum to this slide here. Let's take this out of here. It's really all you're looking at is the less than or the greater than. All right. Next, let's take a look at number 4. Well, that's too much alike the one we just did, so I'm gonna try a different one. Okay, this is not a problem from the book, but it's a rational inequality. Okay, but what do I mean by that? Well, let me get a rectangle here. That's the problem in the box. And we call that a rational inequality because it's a ratio. It's a, you know, it's one thing. It's an algebraic fraction. And it's an inequality because we don't just have a plain equal sign. So how do we solve this? Okay. Well, how, you guys, how would we get rid of -5? I'm sorry, how would we get rid of the denominator x minus 5? Wouldn't you want to multiply both sides by x minus 5? Okay, but here's the problem. If x minus 5 is positive, then will we have to flip this sign? This less than or equal to sign? No, when you multiply by a positive, you don't flip anything. But isn't it possible x minus 5 is negative? Yeah, we don't know what x is. And if it was negative, what happens when you multiply both sides of an inequality by a negative? You have to flip this less than or equal to sign. So guess what? We don't know if it's positive or negative, so guess what? We have to do it both ways. Okay, so this has got a little complexity to it. So, in step 1, I'm going to assume this, that it's positive. Okay? Let's start with that. If x minus 5 is positive, isn't that the same as if you just add 5 to both sides? Doesn't that mean x is bigger than 5? By the way, can x be equal to 5? No, because that would create a 0 down here, and you know we can't, there's no way you can divide by 0. Okay, but if x is greater than 5, then that thing in the blue circle is going to be positive, and we don't have to do anything. So in part 1, we're going to make this assumption right here, that x minus 5 is bigger than 0. So x is greater than 5. All right, do the algebra. So I multiplied both sides by x minus 5. It's gone on the left. And what's 3 times x minus 5? 3x minus 15. Notice I did not change the inequality sign because it was positive. Then I just did a little bit of algebra and I got this answer. By the way, is that compatible with x is greater than 5? Yeah, x is greater than or equal to 8. Those numbers greater than 8 are greater than 5. So there's my part 1 answer. Now, in part 2, I dare not forget about this. What if x minus 5 is negative? What if x minus 5 is less than 0? Well, that would mean that, what? X is less than 5, wouldn't it? Because if you add 5 to both sides. All right. But then, what happens when I multiply by a negative? I got to reverse the inequality sign. I'm putting a couple circles around that. Big deal. So, look, the algebra looks the same. 2x minus 7, 3x minus 15. Same thing we had up here. But you notice this sweetheart is reversed? That's a big deal. So now when I get done with the algebra, on this part I get this. X is less than or equal to 8. Okay? Now, remember, for this part we made this assumption. If x is less than 5 and at the same time it's less than or equal to 8, doesn't that mean it has to be, let's see, how can we put this? If x is less than 5 and it's less than or equal to 8, what's in common between those two is that it's less than or equal to 8. This should really be an 8. Let me redo that. Okay, so what we have here is a split graph. And remember, we said the word or here, and sure enough, that means we got to paste them together. So now if you look at the graph, and I did this in Desmos, the black curve, you see two branches of one up here on the top right and one below here inside the pink. That's the equation that you saw on the left side. That's this rational thing here, 2x minus 7 over x minus 5. And then the pink is everything less than 3. So where is the black curve and in the pink? And the answer is, well, all this curve right here and just from what? 8 right here is where it starts appearing, and then everything to the right. Sure enough, look at what our answer is. Everything to the left of this is over here, and everything to the right of 8. So you see how so where are both conditions met? Everywhere to the left of 8 and everywhere to the right of 8. But you know, that's not right. It's 5. I was right before, and I gotta. You're gonna have to give me a second here to double check on what I missed. Less than 5 and less than. Oh yeah. Okay. So here's the deal. The assumption of x is less than 5 has to be ANDed with the answer we got with that assumption. So where does less than 5 and less than or equal to 8 overlap? Here, let me just show you. We have a graph here, and let's say this is 5, 6, 7, and let's say this is 8. Okay, where's less than or equal to 8? That looks like this. And where's less than 5? That looks like this. And where do they overlap? Where do those two that I just drew overlap? Just the part less than 5. You see that? So that was the correct answer here, 5. And you notice everything less than 5, that's this that's this thing. And then greater than 8, here's 8 that I've circled over here, and everything, it's only what? That part of the curve that's to the right of it. So when are we on that black curve and at the same time less than 3? We have stated it correctly. By the way, do you see why I used a, it's less than or equal to 8. This should have been a solid dot. Do you see why I used a bracket here? Because it includes 8. But here, for the 5, I used a rounded because it's, you know, there's no equal sign there. And there can't be an equal sign, because if there was an equal sign, you'd be dividing by 0. So, I know these are kind of complicated. Let me just recap. Okay, when you have a rational inequality, you use the same old algebra techniques. You multiply both sides by the denominator, and you assure that the denominator can't be 0. And when you multiply both sides algebraically by something, you have to know if it's positive or negative. And the problem with x minus 5 is you can't tell. So you have to do 2 scenarios. If the denominator is positive, then what happens? And that's what's above the line I just drew. And then everything below it is the other one when the denominator is negative. And then you take your 2 answers and you put them together. This is kind of messy, so I'm sure we're going to have to do another one here. Sorry about that. I'm drawing on it to try to, I don't know, try to cover the electronic bases because we're not live. Let's do another one. I think I've got another one right here. Yeah. Well, that's still not the right kind. Let me go down further. No, I want to find... Okay, we may have to just do another one. So let me insert one here. Okay, let's take another problem from 1-8, like how about number 40? That's another rational inequality problem. We got 5 plus 7x divided by 1 plus 2x. And that supposedly, when is that less than 4? Okay, so here's our second example of these. So we all know that I got to get x out of the denominator. There's no way I can solve for x with x on the bottom and x on the top. So I've got to get rid of this guy, right? This 1 plus 2x. So therefore, I want to multiply both sides by 1 plus 2x. That's cool, except I don't know if 1 plus 2x is positive or negative, do I? Couldn't it be both? It all depends on x, and we don't know. So we have to do 2 cases. Let's say case 1. And that is that 1 plus 2x. Should we do the tougher one first this time? Let's say 1 plus 2x is negative. All right. Well, solve for x, and what does that mean? Subtract 1 from both sides, and then divide both sides by 2. It means that x is less than 1. So this is the, we're assuming this in order to get a negative denominator. All right. So now let's do the algebra. Multiply both sides by 1 plus 2x. And because we're assuming it's negative, what must I do with this big old less than thing here? I got to reverse it. So on the left side, when you multiply by 1 plus 2x, the denominator will be gone. Notice I reverse this. And on the other side, we have 4 times 1 plus 2x. Would you all agree? If you take 4 times 1 plus 2x, you get 4 plus 8x, right? Now let's do the algebra. Let's subtract 7x from both sides. Okay. And then let's subtract 4 from both sides. Now look at these two. These two have to both happen at the same time. Less than a half and less than 1. Where do those overlap? First of all, are they compatible? Can a number be less than 1/2 and less than 1 at the same time? Anybody?
Should that be negative 1/2?
Yes, thank you, Jeremy. Yeah, because when I subtracted 1, this should have been a negative 1. So now let's ask the question. Can a number be less than negative 1/2 and at the same time be less than 1? Sure. Like, how about negative 1? Is negative 1 less than negative 1/2? Yeah. Is negative 1 less than 1? Sure. See, what you're doing is you're taking, let's say that's 0, there's 1, and right there is negative 1/2. So if you take the numbers less than 1/2, they look like this. And the numbers less than 1, and they look like this. Is there any overlap between those two graphs? Sure, it's everything less than, where's the overlap? Isn't it right here? So the final answer to our case 1 is x is less than negative 1/2. Answer to part 1. Now, case 2. And that is that the denominator, 1 plus 2x, this time, and this is the more friendly version, is greater than 0. It's a positive. So what's going to happen when I multiply both sides of the inequality by a positive? No change. So, by the way, let's finish this up. Let's see if I can subtract right this time. I subtract 1 from both sides. You get a negative 1 there. Divide both sides by 2. Whoops. And now I get what? X is greater than negative 1/2 for that assumption. All right, so when I multiply both sides of the original inequality by positive, the left side will cancel, and I'll get 5 plus 7x. And this does not change this time. And the right side will be 4 plus 8x. And, you know, it's the same stuff we had up here with a different sign in between. And now subtract 7x from both sides. And now subtract 4 from both sides. Okay, so now we're almost done. I gotta take my keyboard off here. And let's make a little more space. So I need to make these two compatible now. Our assumption was that x was bigger than negative 1/2, and our answer is that x is bigger than 1. So let me make a quick drawing, a quick graph. So we have, again, 0, negative 1/2, and 1. And one answer is that it's bigger than negative 1/2. That looks like this. And the other answer is that it's bigger than 1. Where are those two overlapping? Can you see it's just bigger than 1 is where they overlap? So here's the answer to part 2. So we got our answer from part 1 and our answer from part 2. Just put those together and you've got your final result. So everything less than negative 1/2. So let's write that like this. Negative infinity to negative 1/2. No equal sign. And that's joined together with everything bigger than 1. And I'm using interval notation. You could have used a graph too. I mean, the graphical answer looks like this. 0, negative 1, negative 1/2, 1. So what we're saying is, there's the one part of the answer, and then the other part of the answer. So I think this is what, the book, you'll have to see. What do the directions say for this problem? Solve the inequality and graph this. Yeah, so they want both. So here's the solution in interval notation, and then they wanted you to graph it, and this is the graphical part of that. So those are kind of complicated, those, and you have to do both cases because you don't know if x is going to make the denominator negative or positive. So you have to cover all your base. In fact, it could be either. So you have to look at both parts of that. How are we doing on time here? Okay, getting close. All right, now I'm going to go backwards a little bit. And now let's look at, this is number 19. So this is back to just a good old quadratic again. Solve the inequality and graph it on the real number line. So number 19. X squared plus 8x minus 5 is greater than or equal to 0. Okay, so for a while we're going to just pretend, and we're going to just look at the equal part, because we want to find where does this parabola cross the x-axis first. So do it just like you learned in previous days. And by the way, can you guys see in this line I just underlined, what technique did I use? How did I get there? Well, first I added 5. I got the 5 out of there. Instead of waiting, I'm just going to tell you, I completed the square. Because what's half of 8? 4. And what's 4 squared? 16. And then do you see how I added 16? You remember the old completing the square technique? And then, well, cool, that's a perfect square, so we can write it as x plus 4 squared. All right, take the square roots of both sides. So you'll come up with these two answers. One is negative 4 plus the square root of 21, and the other one is negative 4 minus the square root of 21. Well, here's what those look like. Yeah, here you can either look at my crude example in black here, or if you look in the background, you see this nice smooth curve in the background. There's the Desmos version. Let me just remind you real quickly how you can do that in Desmos. So I'm going to just open up my my browser here. At least I'm going to attempt to. And I'm going to go to Desmos, and then I'm going to share that. Okay, so now let me share a different screen. A little bit of a tech issue here. Just hang on a sec. Share Desmos, share. So you guys should be seeing my graph now. And I forgot which one am I doing. 19. Yeah. So all you have to do in Desmos is come in here. I'll just show you where I am down here. And you can just type in, you see how I just typed in x squared plus 8x plus 5 on the left, and you'll get the graph here. By the way, cool thing about Desmos, if you put your cursor over where it crosses, look, it tells you negative 8.58, positive 0.58. By the way, those are the what? The rational answers for I'm getting there, believe me. Those are the rational answers for these two that I have here, negative 4 minus the square root of 21 and negative 4 plus the square root of 20. Those are the decimal forms. So anyway, the graph that I have in the background here is the one from Desmos. So now, let's not forget, what was I supposed to find out? Not where it crosses, but when does it cross or be above? So can you see from the graph, when is the parabola above? Like here's one, here let me get red. Here's one part of the graph that's above the x-axis, and here's the other part, right? So it's when x is on or to the left of -4 times the square root of 21, or when it's on or to the right of -4 plus the square root of 21. So let's see, how would that be in interval notation? In interval notation, you would write -4 minus the square root of 21, and it goes on forever to the left of that, united with, put the wrong bracket, sorry. Oh, you know what? I forgot, that should be a square bracket, shouldn't it? Because it's on or above. So, and then it's on or below. And on this one, it's on or above -4 plus the square root of 21, and it goes forever to the right. So this would be the interval notation for what we wrote right here. I would accept either of those. I think this one on the bottom is the one you're going to see in the book. Okay, I'm going to hang it up here pretty quickly. We already looked at that one, I think. Yeah, we're running out of time. So anyway, first of all, here's the assignment. 1 to 57 odds. Let me remind you that tomorrow what we're going to do is we'll start with questions on this, and then we'll begin going through the review material for the entire chapter. Then we'll follow that with a full day of review on Friday, test on Monday. Okay, let me give a shot here. I know there was a lot there. We'll see how well this went. And does anybody want to ask follow-up questions, either by text message or from our live participants here? So send them along if you would, please. I can always answer them afterwards. This should be up as soon as we'll bring this to a halt then, and the video should be up. I've already sent you the video link, but you'll find it on our webpage. Okay? Thank you. I appreciate your questions and your participation, everybody out there. Have a good one.
Thank you.
Bye.
Bye.